Python Interview Question Series. Part 5, Python for ML and Gen AI, questions 41 to 50. For students, freshers, and Python developers. Data science, AI, and machine learning. Let's get started. Part 5, Python for ML and Gen AI, questions 41 to 50. 10 questions covering Python in AI, ML, NLP, and LLMs, focus on vectorization, tensors, pandas, tokenizers, and API requests. Clear and concise slides optimized for tech interviews. Let us start with question 41. Why is Python so incredibly popular for artificial intelligence and machine learning? First, its extremely simple and readable syntax means data scientists and researchers can focus entirely on complex neural network architectures and mathematical modeling, rather than fighting with verbose boilerplate code. Second, Python has built an unparalleled ecosystem of libraries over the last decade. It serves as the universal wrapper or control language for high-performance, low-level C++ math engines. When you write a simple line of Python in PyTorch or TensorFlow, it instantly compiles down to execute on massive NVIDIA CUDA GPU clusters or Google TPUs. Python gives you the ease of a scripting language with the raw computational power of compiled C++. Question 42. Explain the difference between NumPy arrays and standard Python lists. This is a very common data science interview question. As you can see in our comparison table, a standard Python list is highly flexible. It can store mixed data types like an integer, a string, and an object all at once. However, this flexibility makes it very slow, because Python scatters these objects randomly across your computer's RAM. A NumPy array, on the other hand, strictly stores only a single data type. Because of this strictness, NumPy can allocate a single, massive contiguous block of memory. This allows your CPU to use what we call SIMD hardware instructions, performing element-wise vector math on the entire array simultaneously without using any slow Python for loops. Question 43. Why is pandas essential in data science? In the real world, raw data is almost never clean. It comes with missing values, duplicate rows, and mismatched formats. Pandas is the industry standard library designed specifically to solve this. It introduces the data frame, which you can think of as a highly programmable Excel spreadsheet running directly in Python. With just a single line of code, Pandas allows you to drop missing entries, interpolate gaps, align time series indices, and filter millions of rows. Furthermore, it contains native, highly optimized readers to parse almost any file format instantly, whether that is a standard CSV, an advanced compressed Parquet file, or a direct connection to a SQL database. It is the mandatory preprocessing step before any machine learning begins. Question 44. What is vectorization? Vectorization is the absolute key to scaling data operations. It is the process of applying a mathematical operation to an entire array or matrix of data at the exact same time, completely eliminating the need for slow, explicit Python for loops. Look at the code on screen. We have two NumPy arrays, A and B. When we write C equals A multiplied by B, we are not looping through index 0, then index 1. Instead, we are telling the underlying compiled C code to push the entire data structure into the processor's vector registers at once. This hardware-level parallel execution, known as single instruction multiple data, makes vectorized operations 10 to 100 times faster than standard Python loops. Question 45. What are tensors? Tensors are the fundamental mathematical building blocks of deep learning and neural networks. Simply put, a tensor is just a multidimensional array of numbers. Look at the table on screen. A zero-dimensional tensor is just a scalar, a single number like a temperature. A one-dimensional tensor is a vector, like a list of word embeddings. A two-dimensional tensor is a matrix, which perfectly represents tabular data or a standard grayscale image. But what happens when you have a color image? You need a third dimension for the red, green, and blue color channels. What if you have a sequence of color images, like a video? You need a fourth dimension for time. Tensors generalize this concept to any number of dimensions, allowing libraries like PyTorch and TensorFlow to process massive datasets. Moving to question 46, explain tokenization in NLP. Natural language processing models, including massive large language models, cannot read text or strings. They only understand numbers. Tokenization is the critical first step where we convert raw human text into numerical arrays. First, the tokenizer splits the input sentence into smaller chunks called tokens. Depending on the algorithm, a token could be an entire word, a subword, or even a single character. Next, the tokenizer maps each of these extracted tokens to a unique integer ID using a pre-trained vocabulary dictionary. In the code box, you can see how the sentence, "I love Python," gets broken down into 3 distinct tokens, and then instantly translated into the integer IDs 100, 342, and 982. The neural network then uses these numbers for training. Question 47. What is JSON and why is it important? JSON stands for JavaScript Object Notation. It is a lightweight, human-readable text format that has become the absolute universal standard for transmitting data across the Internet. Whether you are querying a weather API or sending prompts to ChatGPT, the data payload is almost certainly formatted as JSON. In Python, JSON is incredibly easy to work with because it translates perfectly into standard Python dictionaries and lists. Using the built-in JSON library, the JSON.loads function will parse a raw JSON string from the web directly into a Python dictionary. Conversely, the JSON.dumps function takes your internal Python dictionaries and perfectly formats them back into a JSON text string ready to be transmitted over a network. Question 48. How does Python interact with APIs? In modern software architecture, different services communicate via APIs over the Internet using HTTP protocols. Python handles this elegantly, most commonly using the third-party requests library. There are several standard HTTP methods. GET is used to retrieve data from a server, POST is used to submit a new payload of data, PUT is for updating, and DELETE is for removing data. Look at the code box. We import requests and simply call requests.get on the GitHub API URL. This reaches across the Internet and downloads the response. We then call the .json method on the response object, which instantly decodes the payload into a standard Python dictionary that we can use immediately in our script. Question 49. What is prompt engineering? With the rise of large language models, prompt engineering has emerged as the essential skill of framing your text inputs to guide the AI to produce exactly the output you need. It is not just about asking a question, it is about designing the context. We use system messages to firmly establish the AI's role, for example, instructing it to act as a senior database architect. We use few-shot examples, where we provide the AI with a few perfect input and output pairs inside the prompt so it learns the exact format we expect. Finally, we use chain-of-thought prompting, explicitly commanding the AI to think step by step. This forces the model to expose its logic, drastically reducing hallucinations and making the output highly reliable. Lastly, question 50. How are Python libraries used to build LLM applications? While the AI models themselves run on massive GPU clusters, Python serves as the critical orchestration layer that glues everything together into a usable app. We use libraries like LangChain to build complex pipelines that chain together user prompts, memory modules, external API tools, and the LLM itself. We use Llama Index to connect our own private PDF documents or SQL databases to the AI, creating powerful retrieval augmented generation, or RAG systems. And we use frameworks like Crew AI or AutoGen to instantiate multiple autonomous AI agents, giving them distinct roles and tools, and letting them communicate with each other in a loop to solve highly complex, multi-step business problems. Thank you for watching. Subscribe to SHR Trinity for more videos, training programs, live classes, and career guidance. Like and share if this video helped you. Check out the full 5-part interview series. If you are interested in attending our live training sessions or have any inquiries, all our contact details are displayed right here on screen and are also available in the video description below. Feel free to reach out to us. We would love to have you as part of the SHR Trinity learning community.